close your eyes for just a moment. Not to sleep quite yet, not yet, just to get comfortable. Settle yourself down into your pillow. Feel how soft it is. Feel the warmth of your blanket coming up around you. Take one slow, easy breath in, and then let it all the way out again. There we go. Nice and cozy. Now, tonight we're going on a very special journey. A very slow, very gentle journey. We're not going to rush anywhere. There is absolutely nowhere we need to be, and nothing we need to do, except drift along quietly together and visit some of the most wonderful places in the whole wide sky. We're going to travel through space. Not fast, scary space. Not the kind with flashing lights and rockets roaring and buttons to press. No, no. We're going to float through space. Gently and slowly, like a sleepy leaf drifting down from a very tall tree on a calm autumn afternoon. That kind of space. The quiet, peaceful, enormous kind. The kind where everything moves slowly and there are long, long stretches of nothing at all, and then something so beautiful it takes your breath away. Outside your window right now, if you were to look, though you don't have to open your eyes, you can just imagine it. There are stars. Hundreds of them. Thousands of them. Tiny pinpricks of light scattered across the dark blue sky, just sitting there very patiently, shining away as they have done for longer than anyone can really imagine. They've been doing that every single night, whether you look at them or not. They don't mind. Stars are very patient. And somewhere in amongst all those stars, or rather at the very heart of our own little corner of the universe, there is a sun. Our sun. The same warm, golden light that came in through your curtains this morning. It's very far away now, resting on the other side of the world, but it's still there, sending its warmth out in all directions like a very generous parent who wants to make sure everyone is all right. And all around that sun, moving in slow, lazy circles, are the planets. 8 of them. 8 beautiful, completely different, wonderfully strange worlds, each one making its own long journey around the sun, year after year after year, never stopping, never hurrying, just going round and round in the great, quiet dark. Tonight, We're going to visit every single one. We begin at the sun. Now, we won't get too close. The sun is very, very hot. Extraordinarily hot. If you could somehow travel to the surface of the sun, it would be about 5,500 degrees. That's not a number that really means anything to most of us. But let's put it this way, it is far, far hotter than anything you have ever felt. Hotter than a fire. Hotter than an oven. So much hotter that there simply aren't any good words for it in everyday life. But we can look at it from a safe distance, and when we do, it is the most extraordinary thing. A great glowing ball of light and fire and swirling golden gases, so big that if you could hollow it out and put the Earth inside it, you could fit 1 million of our little Earths in there and still have room for a few more. 1 million Earths. Isn't that a thought? The sun has been burning away like this for about 4.5 billion years. Before you, before your parents, before their parents, before every great-grandparent, stretching back and back and back through all of history, before the dinosaurs, before the fish, before the first tiny creatures that ever crawled up onto land. The sun was already there, shining. It was there before the Earth itself existed. And scientists think it will keep burning for another 5 billion years or so. By then, everyone reading this story will be very, very well rested indeed. The sun is the reason everything in our solar system is here. It is the anchor. Everything. Every planet, every moon, every little floating rock is pulled towards it by something called gravity, and that pull keeps them all circling round and round in their slow, steady paths. The sun holds everything together. The way a kind grandmother sits in the middle of a large family and holds everyone together just by being there. We'll stay here for just a moment, floating quietly at a safe distance, feeling its warmth. Then we'll start moving, slowly, away from it, out into the darker and cooler regions of space, visiting each planet in turn. The first planet we come to is called Mercury. Mercury is a small planet. It's the smallest of all the planets, actually. If the Earth were the size of a football, Mercury would be about the size of a small marble. A slightly grumpy-looking small marble, at that, because its surface is covered in dents and craters, little round holes made long ago when rocks from space crashed into it over millions and millions of years. It hasn't been hit quite so much lately, but the marks are still there, like little memories of when it was young. Mercury is the planet closest to the Sun. You might think that means it is the hottest planet. And during the day it is terribly hot. Hot enough that certain metals would melt right there on the ground, just sitting in the sunshine. But Mercury has almost no atmosphere, no thick blanket of air around it the way Earth has. And so at night, without that blanket to hold the warmth in, the heat just drifts away. Out into space. And Mercury gets incredibly cold, colder than anywhere you've ever been. Colder than the deepest, most frozen part of the polar ice. All in the same day. Imagine waking up in summer and it being hotter than any oven. And then by bedtime being colder than the very coldest winter. That is what every single day is like on Mercury. Mercury moves very quickly around the Sun, much more quickly than we do. A whole year on Mercury. The time it takes to go all the way around the Sun once is only 88 of our days. So if you lived on Mercury, your birthday would come around 4 times a year, which sounds like rather a lot of birthday cake. We pass Mercury slowly, nodding hello to its cratered, quiet face, and we drift on. The next planet is Venus. Ah, Venus. Venus is very beautiful from a distance. When you see it in the sky, and you can see it, it is the brightest thing in the sky after the sun and the moon. It looks like a soft, pale, silvery light. People have always loved looking at Venus. Sometimes it appears in the west just after the sun sets, and people call it the evening star, though it is not a star at all. Sometimes it appears in the east just before the sun rises, and they call it the morning star. Either way, it is lovely to look at. But up close, Venus is not quite as pleasant as it looks. Venus is covered, completely covered, in thick, heavy clouds. Not the white, fluffy sort of clouds we have here, floating gently above our heads. These are thick, yellowish clouds made of something called sulfuric acid, which is very nasty indeed, and they trap all the heat from the sun underneath them. Because of this, Venus is the hottest planet in the whole solar system, even hotter than Mercury, even though it is further from the sun. The temperature on Venus is about 465 degrees, hot enough that if you put a piece of lead on the ground, lead is a heavy gray metal. It would sit there and melt like butter in a warm kitchen. Everything on Venus moves in the opposite direction to most other planets. If you were standing on Venus, which, to be very clear, would not be a comfortable experience, the sun would rise in the west and set in the east. The wrong way round. Very confusing. And a day on Venus is actually longer than a year on Venus. It takes longer to spin around once than it takes to go all the way around the sun. so by the time it had been a full day, the year would already be over. Venus is about the same size as Earth, which is probably why astronomers sometimes call it Earth's twin. But it is a twin who made some very different choices. We give it a little wave as we pass, grateful for our own cooler, friendlier home, and we drift on. And here we are now, is Earth. Our home. From out here in space, drifting quietly past, the Earth looks like, well, it looks like the most beautiful thing you have ever seen. It is blue. A deep, rich, gorgeous blue because most of it is covered in oceans. And then there are swirls of white cloud, slow and peaceful, drifting across the surface. And patches of green and brown where the land is. And at the poles, a soft, bright white where the ice is. It glows. That is the thing about Earth that always strikes people who have seen it from space, and a few lucky astronauts have. It glows. It is alive in a way that no other planet we have found is alive. There is weather on it, and seasons, and tides, and rivers running down from mountains to the sea. There are forests, and deserts, and meadows, and deep, cold ocean trenches where strange fish live in the dark. There are small villages and enormous cities, and everywhere, there are people and animals and birds and insects and plants all quietly getting on with their lives. And right now, somewhere on the night side of that blue spinning ball is a small warm house. And in that house is a cozy room. And in that room, under a soft blanket, is you. Isn't that a nice thought? The Earth takes 365 days to go around the Sun. That is 1 year, our year, the year that all our seasons fit into, the year that has your birthday in it somewhere. And while it is going around the Sun, it is also spinning, the way a top spins. And it takes 24 hours to spin all the way round. That is 1 day, our day. The day that has your breakfast and your lunchtime and your evening and your bedtime in it. Earth has one moon. Just one. A round, pale, quietly wonderful moon that travels around the Earth in its own slow circle, taking about a month to go all the way around. The moon is not alive. There is no air on the moon, and no water, and nothing grows there. But it is there, every night, and it gives us light when the sun has gone, and it pulls on the oceans and makes the tides go in and out. It has been doing that for 4.5 billion years, faithfully, without any fuss. We are very lucky to live here. We take one last long look at our beautiful blue home, and then, gently, we turn and drift away again, further out into the solar system. The next planet is Mars. Mars is smaller than Earth, smaller and redder. The whole planet is a dusty, rusty red color, a sort of orange-red, like old terracotta pots or dried-out clay. This is because the rocks and soil on Mars are full of iron, and the iron has rusted. That's right. Mars is red because it is rusty. The whole planet, rusted. The sky on Mars is not blue like ours. It is a sort of pale pinkish color, or sometimes, when there are dust storms, it turns a deeper brownish red. Mars has enormous dust storms sometimes, storms that can cover the entire planet and last for months. Imagine that. A storm so big it wraps all the way around the whole world and keeps going for months. Very dramatic. Although by now you'll be pleased to know that we are drifting past in our quiet, comfortable way, and none of that will bother us at all. Mars has some very impressive features. There is a volcano on Mars called Olympus Mons, and it is the largest volcano in the entire solar system. It is 3 times as tall as our Mount Everest, which is the tallest mountain on Earth. 3 times. It is so wide that if you were standing at the edge of it, you wouldn't be able to see across to the other side. The planet would curve away before you got there. Can you imagine a mountain that enormous? And there is a canyon on Mars called Valles Marineris. On Earth, the Grand Canyon is considered a rather large canyon, and people travel a very long way just to look at it. Valles Marineris makes the Grand Canyon look like a small scratch in the ground. It stretches nearly a quarter of the way around the whole planet. It is as long as the width of the whole United States. Mars has 2 moons. They are not like our moon. Our moon is big and round and rather grand. Mars's moons are small and lumpy and oddly shaped, more like large potatoes than proper round moons. Their names are Phobos and Deimos. Phobos is so close to Mars that it actually goes around the planet faster than Mars spins, which means if you watched it from the surface, Phobos would rise in the west and set in the east. The wrong way round. It is also slowly drifting closer and closer to Mars, and in about 50 million years or so, it will get so close that Mars's gravity will pull it apart. But that is a very long time from now, and there is nothing to worry about. We say a quiet goodnight to the rusty red planet and keep drifting. Now, between Mars and the next big planet, there is a very long stretch of space. And in that space, there are millions and millions of rocks. This is called the asteroid belt. These are not enormous rocks. Well, some of them are fairly large, but mostly they are smaller ones, ranging from the size of a house down to the size of a pebble. They float along in a great wide ring around the sun, tumbling slowly, bumping into each other occasionally in a very gentle, unhurried sort of way. They have been there for billions of years, these rocks. They are leftovers from when the solar system was being made, little bits and pieces that never quite came together to form a proper planet. The biggest object in the asteroid belt is called Ceres, and it is round enough that scientists call it a dwarf planet. It is about 900 kilometers across, which sounds big, but is much smaller than our moon. Ceres has water ice on it, perhaps quite a lot of it, hidden under its dusty surface. As we drift through the asteroid belt, gently taking our time. It is not as crowded as you might imagine. The rocks are spread across such a huge area of space that you could sail right through and never come close to hitting one. It looks like a lot from a distance, but up close, there is mostly just the quiet dark, with a little tumbling rock here and there, drifting past in its own patient circle. We pass through without any fuss at all, and on the other side, things start to get bigger. Much bigger. Here is Jupiter. Oh my. Jupiter is enormous. It is the largest planet in the solar system by a very long way. All the other planets put together, every single one of them, would still not be as big as Jupiter. It is 11 times wider than Earth. If Jupiter were hollow, you could fit 1,300 Earths inside it. 1,300. It is not a rocky planet like Earth or Mars. Jupiter is what scientists call a gas giant. It is made mostly of gas, mostly hydrogen and helium, the same kinds of things that make up the sun. There is no ground to stand on. If you tried to fly a spaceship into Jupiter, there would be no surface to land on. You would just sink slowly deeper and deeper into thicker and thicker gas, and the pressure would get stronger and stronger until eventually you would be squeezed very flat indeed. This is not recommended. What you can see of Jupiter, the part you look at from space, is its cloud tops, and they are beautiful. They are arranged in wide, swirling bands of color. Pale yellows and oranges and creamy whites and soft browns, all moving in different directions, sliding past each other like slow rivers of cloud. And right near the south of Jupiter, there is one enormous oval-shaped storm. It has been going on for at least 350 years, possibly much longer. We just haven't been watching it for longer than that. It is called the Great Red Spot, and it is bigger than the entire planet Earth. It is a storm the size of a planet, and it has been going round and round for hundreds of years, and nobody knows exactly when it will stop. Jupiter has lots of moons. Lots and lots of them. Scientists have found nearly 100 of them so far, though most are small. But 4 of them are very large and very interesting. They were spotted by a man called Galileo over 400 years ago when he turned his small telescope towards the sky and looked. He could see these 4 little points of light moving around Jupiter night after night. They are called Io, Europa, Ganymede, and Callisto. Europa is the one that makes scientists very excited and very thoughtful. Underneath its icy surface, there is an ocean. A real liquid ocean, kept warm by heat from Jupiter's gravity, pulling and squeezing the moon as it goes around. It might be one of the best places in the entire solar system to look for life, if life exists anywhere else at all. Not life like us. Probably not little green people. But perhaps very simple, tiny creatures, the way the very first life on Earth was. Just the idea of it is rather wonderful. A hidden ocean on a cold moon far from the sun, keeping its secrets. We drift past Jupiter slowly, looking up at its enormous swirling face, and we carry on. The next planet is Saturn. And Saturn it is like someone made a planet and then added something just to make it more beautiful. Because Saturn has rings. Not just a little ring, enormous, sweeping, dramatic rings. 7 main rings made of billions and billions of tiny pieces of ice and rock, ranging from the size of a grain of sand to the size of a house, all orbiting around Saturn in a flat, perfectly smooth disk. If you were able to zoom out and look at Saturn from a distance, it would look like someone had drawn a circle around a planet with a very wide, very neat pen. It is arguably the most beautiful thing in the solar system. Saturn is the 2nd largest planet, after Jupiter. It too is a gas giant, made mostly of gas, no solid ground. And it is so light for its size, so full of gas rather than heavy rock, that if you could find an ocean big enough to put it in, Saturn would float. Imagine a planet that would float in water. Like a bath toy. The biggest, most beautiful bath toy in the solar system. Saturn has moons as well, and one of them is called Titan, and Titan is extraordinary. Titan has a thick atmosphere, thick like our Earth's atmosphere, the kind that makes the sky a color rather than just being black. Titan's sky is a deep orange. And on Titan it rains. But not water rain, it rains methane. Liquid methane drips from the orange sky and collects in rivers and lakes. There are lakes of liquid methane on Titan. The whole thing is freezing cold, about minus 179 degrees. And if you could somehow walk around on Titan in a very warm suit, everything would look like a cold, foggy, orange version of Earth. Very strange and very alien and oddly beautiful. We spend a long, quiet moment just looking at Saturn's rings catching the distant sunlight, and then we drift on. We are getting further from the sun now. Things are darker here. The sunlight is weaker, thinner, more like the light late in an afternoon than the bright light of midday. It is very quiet out here. Very, very quiet. The next planet is called Uranus. Uranus is another gas giant, though it is smaller than Jupiter or Saturn. It is a pale blue-green color, like sea glass or the color of shallow water over sand. It is a calm, soft color. Peaceful. What makes Uranus rather peculiar? Gently peculiar, not alarming peculiar, is the way it is tilted. Every planet has an axis, an imaginary line going through the middle from top to bottom, and the planet spins around that axis. The Earth is tilted a little, just enough to give us our seasons. But Uranus is tilted almost all the way on its side. It is tilted 98 degrees. That means it is essentially rolling around the sun on its side, like a ball rolling along the ground rather than a top spinning upright. Nobody is entirely sure why. Something must have bumped into it very hard, a very long time ago. Some enormous rock, early in the history of the solar system, and Uranus just went over sideways. And has been that way ever since, quietly rolling along on its side, year after year. Because of this, Uranus has very strange seasons. The part of Uranus pointing towards the sun gets about 42 years of continuous sunlight. Then, as it rolls around to the other side of its orbit, that part faces away from the sun for 42 years of darkness. 42 years of night. And 42 years of day. A very long season indeed. Uranus also has rings, though they are much thinner and fainter than Saturn's and rather dark and hard to see. It has moons too, 27 of them, and they all have names taken from the plays of William Shakespeare and from poems by Alexander Pope. Miranda, Ariel, Umbriel, Titania, Oberon. Pretty names for cold, distant, quiet little moons in the dark. We pass Uranus gently, nodding at its pale blue side, and we move on. And here, at last, is the furthest planet of all, Neptune. Neptune is the deepest, richest blue you can imagine. Not light blue, not the pale color of a winter sky, a deep, vivid, royal blue, the color of the deep ocean, the color of dark water at night. It is beautiful in the way that the sea at night is beautiful. Calm on the surface, enormous and deep underneath. Neptune is a long, long way from the sun. Such a long way that sunlight takes 8 minutes to travel from the sun to the Earth. 8 minutes. But from the sun to Neptune, it takes 4.5 hours. The sun, from Neptune, looks like just a very bright star. Very bright, but a star-like point of light in the sky, not the great glowing disk we see. It is very far. Because it is so far from the sun, a year on Neptune. The time it takes to go all the way around the sun once is 165 Earth years. Neptune was discovered in 1846. It only completed its very first full orbit since being discovered in 2011. Its second orbit won't be finished until 2076. A Neptune year is so long that no human being has ever lived long enough to see one Neptune year pass. Neptune has winds, extraordinary, howling, almost unimaginable winds. The fastest winds in the solar system. They can blow at over 2,000 kilometers per hour. On Earth, a powerful hurricane might reach 300 kilometers per hour and cause tremendous damage. Neptune's winds are 6 or 7 times that speed. The whole planet is wrapped in vast howling storms, swirling in the deep blue cold. And yet, from far away, it looks calm. Just a deep blue sphere, drifting quietly in the dark. All that howling is happening inside and on the surface, but from a distance, Neptune just looks peaceful. A beautiful, quiet, dark blue ball in the cold black of space. Neptune has 14 moons that we have found so far. The largest is called Triton. And Triton is very unusual because it orbits Neptune the wrong way round, the opposite direction to everything else. It is also slowly spiraling inwards, very, very slowly, getting a tiny bit closer to Neptune with each orbit. And in about 3.5 billion years, it will get close enough that Neptune's gravity will pull it apart. But that is a very, very long time from now. We stop here for a moment, floating very still, looking back the way we have come. And it is the most extraordinary view. From here, from Neptune, the sun is just a point of light. A brilliant, steady, unwavering point of light among all the other stars. You would have to know which one it was to pick it out. And yet, that tiny point of light is warm enough to grow every flower and fruit on Earth, warm enough to make the oceans sparkle, warm enough that right now, on the other side of the planet you call home, the sun is shining and making someone's morning very golden and bright. And all around that little point of light, in their great, slow circles, are all 8 planets. Going round and round. Mercury with its scorched and frozen face. Venus with her thick yellow clouds. Our Earth, so blue, so alive. Rusty Mars and his lumpy moons. Enormous Jupiter and his ancient storm. Beautiful Saturn with her rings like a crown. Sideways Uranus, quietly rolling. And us here at the edge with Neptune's blue light all around us. The solar system. All of it, stretching from here back to that little bright star that is our sun. 180 times further away from the sun than we are at home on Earth. So far, that if you drove there in a car without stopping, it would take about 6,000 years. And beyond Neptune, there is Pluto, a small, cold, heart-shaped little world with a reddish-brown surface and mountains of ice. And beyond that, there are other small icy worlds drifting at the very, very edge of the sun's influence. And beyond those, other stars with their own planets, their own moons, their own ancient storms, their own cold, dark moons, perhaps with hidden oceans keeping quiet secrets. There is so much space. So much quiet, enormous, beautiful space. Now, it is time to come home. We turn very slowly, and we begin the long drift back. Past Neptune's deep blue light fading behind us. Past Uranus tilted gently on its side. Past Saturn's glowing rings. Past Jupiter's swirling cloud tops. Past the little tumbling rocks of the asteroid belt drifting along in their patient way. Past Mars, red and dusty and quiet. Past Venus, bright and cloudy. Past Venus, bright and cloudy. And here is the sun, warmer now, closer now, and circling around it, third from the sun, is a blue sphere. Our blue sphere. Getting closer now. Growing from a small bright marble to something larger, something familiar, something loved. There are the oceans. There are the clouds. There is the green of the land. And somewhere on the night side, the dark side that is turned away from the sun right now, there is a small country, and in that country, a town or a village or a neighborhood, and in that neighborhood, a house. And in that house, a cozy room. And in that room is a bed. And in that bed, there is a small, warm, sleepy person. And they are nearly asleep. The solar system is very large and very old. It has been here for 4.5 billion years. The planets have been going round and round in their slow, steady orbits for all that time, in the dark and the cold and the occasional warmth. Long before anyone was here to look at them, long before there were eyes to see them or words to name them, or stories to tell about them. And every night, when the sky goes dark and the stars come out, all of that is still up there. Jupiter still turning slowly. Saturn's rings still catching the sunlight. Neptune still howling in the far dark blue. The asteroids still tumbling gently. The moons of Jupiter still keeping their ancient silent vigil around that great striped giant. It is all still going on right now while you lie here warm and still. And perhaps that is a nice thing to think about. All of that out there, all of that tremendous, vast, ancient, beautiful machinery, all those worlds turning and orbiting and spinning in the dark, and here you are, safe and warm and small and tucked up, and all you have to do is breathe slowly and let your eyes close and drift off to sleep. The planets don't hurry. They never have. They have all the time in the world, all the time in the universe. And so do you tonight. There is nowhere to be and nothing to do, and everything is exactly as it should be. Jupiter is still turning. Saturn's rings are still there. The sun is still shining on the other side of the world. And you are drifting off now, slowly, gently, like a leaf on still water, like a cloud across a pale sky, like a planet moving through the dark on its long, quiet, unhurried journey around the sun. Round and round and round and round. Slowly. Slowly. Good night.